let's move on. Mike and Vitaly have told you to go deeper when testing. I'm actually telling you to look up and sideways. There are way more environments to test on than only KVM itself for KVM unit tests. I'm Janosch Frank, the co-maintainer for KVM S390, and at the beginning of the year I've been pulled into firmware testing and firmware development, and I needed a test vehicle to test on the machine and under different hypervisors, and naturally for me I chose the KVM-unit-tests. So we'll have a look at how KVM-unit-tests are used at IBM, or used at all, I guess, why we want to move to other hypervisors and run on the machine, what we needed to do to make them run, and what we found in the process. And then we'll have a short look into the future. It seems like the audience doesn't like KVM-unit-tests that much. I really love them. They are small, they are reliable, they are very fast, and they are dead simple to write. So when a new developer comes to me and asks, well, I need a testing framework, I tell them, if it doesn't need a lot of configuration, use KVM-unit-tests. You will just need half an hour to write a test case, and you'll be set for life, hopefully. KVM-unit-tests on S390 are used to do architecture, compliance testing, testing of new facilities that come with new machines, regression testing. Sometimes I give out custom unit tests for error reproduction, so our testers can use them in the field, and also for backport verification. KVM was mostly the host before I started development on my changes. KVM-unit-tests were mostly run in a manual environment by the developers when they wrote their new code, mostly on hardware virtualization, about 1% with nested virtualization. Then we also integrated a CI environment into our build environment, and we now have automated full runs of the KVM-unit-tests, where we run the tests on multiple hardware and firmware levels and with nested virtualization. In between there's also a second hypervisor, CVM, which acts as a host to KVM, so we are also testing parts of the CVM hypervisor. All of that is only done on S390 hardware, so no TCG tests. So why did I want to run on more environments that we supported at the beginning of the year? Well, when I came into firmware development, I saw that we had a lot of testing kernels, like really large amounts of them. Most of them don't run on all hypervisors, and we as KVM try to make some of them run on KVM because they provide immense testing features which we are currently not using. We have a great architecture compliance assurance kernel, a fuzzing kernel, which is really great to find some errors in stressing situations. Handwritten loops which are mostly used by the firmware to check specific instructions and so on. And I think at least 5 frameworks similar to KVM-unit-tests. And most of the time, one person is responsible for the whole project, and that's a real bummer, because you need to know that person to get the code and to get the kernel and then be able to run it. You're left out if there are new versions of that kernel. It's annoying. We also have a lot of environments to run on. We have 3 hypervisors, 2 levels of hardware virtualization. We have emulation on TCG and on CPDT, which is also x86 emulation for S390. We have lots of firmware simulation, and we have various firmware levels on various hardware levels. All of them affects how an instruction is actually emulated. Most of the time, it doesn't change the output of an instruction, or it does in an architectured way, but sometimes it changes the output of an instruction where we don't want any change. For example, CVM handles page table management for guests way different than KVM, and so the nesting is a bit different from our nesting if you have a look at it. So I set out at the start of the year, and my goal was to make the Kvm-unit-tests run on as much environments as possible, as much hypervisors as possible. Hopefully, we'll see some testing differences between the tests on different hypervisors. Maybe some of them are implementation errors. In any case, we'll learn something about the architecture and the hypervisors. I also wanted to push Kvm-unit-test adoption into the other teams, so they have something that's open source, where they can just grab the source and run it for their testing needs. The more people use Kvm-unit-tests and hopefully then write bug reports, the more coverage we have. So the hardest part at the start was getting it to boot at all, because Kvm-unit-tests are booted as via the kernel, direct kernel boot with QEMU, and well, that doesn't work on a machine level. The machine doesn't understand ELF binaries. So it's very KVM specific how they're compiled. Other hypervisors expect a binary to be loaded into memory, and then in memory at specific offsets there's an entry address which is used as the first address the booting CPU receives, and then it starts off from there. Also, we have no moving of ELF sections, and we have no clearing, so we needed binary test case generation. We made the assumption that we'll always run under 64-bit extended C architecture, which is not always the case depending on the machine you're running on. But we also want to be able to run the Kvm-unit-tests on old machines, because sometimes for instructions that give information about the machine, they provide less data or they provide strange data, which might be interesting to test. Well, then the tests booted up, but unfortunately I was greeted by basically a white screen, because the console absolutely didn't work. In the Kvm-unit-test, we made the assumption that when we set out and executed the instruction that's responsible for the console, we would get the interrupt together with the end of the emulation of the instruction. So we never waited for the interrupt. That's okay for QEMU, because it's implemented that way, but on LPAR, on the machine, and on CVM, that's just not the case, and the test case would just run on. At some point in the future would receive the data, and the interrupt would just ignore the interrupt and work on zeros. That didn't work out great. Also, we expected that the console is ASCII. Yeah. The mainframe mostly uses EBCDIC, so we needed to create a second console stream in addition to the ASCII console. So we're now outputting ASCII and EBCDIC in parallel to actually get any output at all.
Is this already upstream? Because I would love to commit a patch that includes an ASCII to EBCDIC converter. It would like the sole opportunity in my life to do that.
Yeah, it's upstream.
Okay, today.
All right. So now with being able to run the tests on multiple environments, multiple hypervisors, I set out, and the easiest target to have a look at was the console, because it's just a massive interface. I think it's more than 100 or 200 pages of documentation. It's immensely complex, and the initial implementation, I think, was just made to make Linux work as a guest. So I wrote a simple test case for the console. I started it under the LPAR hypervisor, and then I started it under KVM, and some differences showed up. Unfortunately, I didn't have enough time at that point to go on, so I asked a colleague of mine, Claudio, to go on with testing, and together we fixed quite a few problems where mostly error cases were wrong priority, wrong thing to error reports. So that was really nice to have. Then, as I said, I started out because I wanted to do some help with firmware development. And the firmware developers needed some help with pre-release firmware and hardware. So I took the Kvm-unit-tests and ran them under KVM, under LPAR, and in simulation. And that was really great because under LPAR, I found errors in the implementation, and then I could just provide the test case, which is really small, just 150K, to the firmware developers, and together with them, I could step through the firmware code, which was run when the instruction was emulated, but when the instruction was being processed in the processor. We could look at the registers inside of the CPU, the internal registers, the state, and internal instructions which are used to make up one whole instruction. Also in simulation, we were able to actually update CPU firmware much faster than on the machine. It only takes a few seconds. On the machine, it takes about 2 to 5 minutes. That depends. So we improved turnaround times, and the firmware developers were very happy to have it. I made some smaller changes, some smaller fix for the store hypervisor information instruction, which provides information about the environment OS is running on. The test ran in a new environment which was previously untested. It was a very old machine where CVM was the first hypervisor and KVM was then the nested. And in there, the input for that instruction was 0, but KVM produced 0 output and then also said, well, the field is valid. But 0 is not a valid data output for that field at that point. So I wrote a KVM fix. Well, I also wrote the store hypervisor instruction emulation, so that was actually my fault. Then I ran the storage key test under CVM and under KVM, and I saw some fails on the CVM, and that's because I made some wrong assumptions when I wrote the test case, so I needed the test case. I needed to fix the test case. I also fixed that, and now we have much more coverage over more environments. Looking into the future, I have to say, covering more environments is great, but as we had the discussions before, we need to really automate testing under these environments. I want to have CI inclusion of LPAR, CVM, and nested KVM, which is currently not the case. I want to have CI inclusion for TCG, so I know that people who use TCG are not affected by changes to the Kvm-unit-test or changes to QEMU. I want to push those tests to early firmware and hardware development. So I get bug reports way earlier than we normally use to get them on KVM. Problem is, integrating these tests is way harder than on KVM because we don't have a lot of tooling for CVM and for LPAR or for the simulation environments. We can boot those tests under LPAR via disk or via SFTP, which is a real pain because we need to compile them, we need to move them to SFTP, and then boot them one by one, extract the console output via some really strange interfaces, and pass them. CVM could actually use a virtual punch card reader to execute those tests. I'm not joking. It might actually be a valid use case for the punch card reader. Looking at the future of Kvm-unit-tests for s390, I want to add some nested test cases. We have a huge blind spot when doing I/O. Problem with I/O is it usually needs a lot of configuration. It's not always enough to just append some command line arguments to QEMU and just be done with it, like for SMP when increasing the number of CPUs. And I want to do way more work under SMP, more stressing of CPU signaling and yielding because we had problems in the past at these points. Another thing that was also mentioned before is if we add new features, we might add more complexity, and that will make it harder for new developers to come to the Kvm-unit tests and use them as an easy-to-use test vehicle. So we really need to make sure that our changes don't affect new users and the whole library gets too complicated. And I set out at this presentation to actually ask you and maybe also network with some of you. Do you actually test on multiple platforms, multiple hypervisors? What kind of differences did you find when testing between these hypervisors, and maybe were there any expectations when writing QEMU and KVM code which actually weren't completely right, but you made them and now something is wrong in the implementation? And with the words of Linux, I'm gonna let you out to lunch. Go out and test. Thank you.
Any questions?
So you mentioned that there were approximately 5 internal
at least, yes.
Test suites that are similar to Kvm-unit tests, and that you want to convince them to use something more common like Kvm-unit tests. Did you succeed? Is anybody switching to Kvm-unit tests now?
I currently don't know. I had a discussion at the beginning of the year with Martin Schwiedewski, and I tried to convince him. And he just told me, well, yeah, like 5 years ago, I wrote that test library, and it basically looks exactly like Kvm-unit-tests. I've yet to present about the Kvm-unit-test within our internal developer meeting, and I hope to push adoption to the Linux developers in Böblingen.
How do these other unit test libraries or mechanisms solve the problem of booting and getting the output from the LPARs?
Well, they were initially written for LPAR and CVM. And the problem for us is that we don't really have a full pass-through of a lot of devices. We are really focused on vidIO. It's basically the other way around for us.
Yeah, so that question is basically a follow-up on this one, just the other way around, because you mentioned I/O testing with Word.io. As far as I am aware, the only implementation of Word.io on s390 is QEMU, or have any of the other hypervisors like CVM now gained some kind of Word.io implementation?
I don't think so, no.
Okay, looks like no other questions. Thank you.